Hello there, and welcome back for another set of definitions. And I promise we're not going to do math here. Those of you who know me know that I love math and I try to work it in anywhere I can. But this is not going to involve numbers. It is a math term, but I won't have you doing any calculation, I promise, on this one. Okay, the first term here is behavior. And you know what this means if you think about it. It is the way one acts. You could say that children have good behavior or bad behavior, the way one acts. A cold-blooded animal is one that has an internal or an inside temperature that varies or changes with the environment. So let's think about humans for just a minute. Does human body temperature vary? Does it change? Yes, it does. If you have a fever, your temperature is higher than your normal 98.6. But does it change with the environment? If I go outside and it's 0 degrees, it's very, very cold. Does my body temperature drop to 0 degrees, or does it stay at 98.6? It stays. As long as your heart is beating and you are alive, your body temperature will stay at that 98.6 mark unless you're sick. Something is affecting it. Humans are not cold-blooded. Cold-blooded means that my temperature would drop to 0. An example of cold-blooded is a snake. If you've ever seen a snake that has crawled out onto the road and been run over, the reason he crawled out onto the road is because the road is warm. And if he can get out there on that warm pavement, his body temperature is going to rise as well. Alligators, crocodiles are others that have that same cold-blooded. They have to stay in a warm place or they won't survive. This is why you don't see snakes in the winter. They den, they hibernate because their bodies can't survive that changing temperature. Instinct is a behavior an animal is born with. Or let's say that an animal is born knowing how to perform. You don't have to teach a person something that is an instinct. Babies have the instinct to nurse. They have the instinct to suck because that's how they get milk. That's how they survive. Dogs and cats do lots of things from instinct. They just know to do things. They have the instinct to hunt. They have the instinct to stay together in a pack. Those are things that they're just born knowing how to do. You do not have to teach someone an instinct. A reflex is an action that's done without conscious effort. Let's say that I am conscious effort. That I am walking down the road on, I'm exercising and I'm walking down the road very fast, and all of a sudden a baseball comes flying at my head. What am I going to do? Well, my reflex, first of all, my eyes will blink. I don't have to think about that. And I'm probably going to duck out of the way. I don't have to think about it. It's just an action that I do without conscious effort. symmetry. This is a math term, but let me give you the science perspective on that. Symmetry is having identical parts or traits. And I've drawn some shapes here. I want to use my a different color pen to draw some lines, and I want you to help me decide if these are symmetrical. So let's do, first of all, this one. Let me zoom in here. This is symmetry, and I should make it right through. This is going to be hard, guys, for me to nail it. Maybe that's going to do it. Yes. This is a line of symmetry because this makes mirror images. I could fold this triangle on that red line and it would match. It would measure exactly the same on both sides. What about this one? What if I draw the line this way? If you fold the triangle on that line, will it match up? No. That is not a line of symmetry. But this one, well, let me go back. Maybe no. This one is a line of symmetry. Okay. On this one, let's draw a line this way. Would they match if I fold them on the red line? Yes, they would. What about if I cut this way? Would they match? Yes, they would. That is a line of symmetry. So sometimes you can have lots of lines of symmetries. It just depends on the shape. But that one is, yes, that is symmetrical. This one's a good one. If I do it this way, would they match if I fold on the red line? Yes, they would. What if I do it this way? Yes. Or this way. Well, not right there, it wouldn't. If you get it right in the middle. Yes, so that one is symmetrical. It is yes on symmetry. How about this one? This one's tricky at first thought. Because if I drew the line right here, fold it, they're not going to match. What if I drew the line right here? Fold it, they're not going to match. So the first thought is to say that is not symmetrical. There's no way that I could fold it that it would be symmetrical. But what if we go this way? That one? No. What if we move it up a little and go this way? That doesn't look symmetrical to me. The proportions of the triangle just don't look right. But I'm not sure. It's not drawn to scale. That has the potential to be a line of symmetry if the sides are the right length. Obviously, this would not be. But you could make a line of symmetry if your dimensions were exactly the same on both sides there. The way it's drawn, I don't think it's symmetrical. I don't see how it would be exactly the same. Maybe right there. Maybe.
I don't know if I can answer that properly.
I'm sorry about that. My cell phone decided to listen in and answer my question. So I'm going to say no on this one. It just eyeballing it, it does not look like it would be symmetrical. But you get the idea. Parts or traits. I deleted that. Okay, we'll put a question mark there because it's hard to tell without actually measuring and drawing something to scale. Okay, the last one is warm-blooded, and that means that internal temperature stays constant. And this is human traits, the internal temperature stays constant. It doesn't matter if you're in a really cold room, if you're in a really hot room, your body is going to maintain that 98.6 degree temperature, because that's what's necessary for human life to exist. So humans are warm-blooded creatures. Okay, guys, I'm going to stop this video because the chart on the next page will take a little bit of time. And I can't remember, yes, we were on page 136. And the chart on the next page is very similar to the one on 136, but I want to go over this with you and explain a little bit more about it. So I'll see you in the next video, and we'll get that done.